Okay, so this video is more related rates. And you can see that in the notes, it's all set up for you for a place to draw a picture, write whatever information you already know, figure out what the equation is you're going to use, etc. Okay, so here we go. A 25-foot ladder is leaning against a house. Let me draw this picture. So we've got the wall, the floor, the ladder. The base of the ladder is pulled away from the house. Okay, so that means this ladder is sliding this direction. This is what I'm going to call the x-axis. So that means that dx dt is 2 feet per second. And then we're asking, or it's asking how fast is the top of the ladder moving down the wall. So the top of the ladder is going down this way. This is the y-axis. So we're trying to find dy dt. Specifically when the base is 7 feet from the house. So when x is 7. Okay, now because I know that this ladder is 25 feet tall, and I've labeled this as x, which is changing, and this as y, which is also changing, when you're looking for an equation, is there any equation you already know that relates the two sides of a right triangle along with the hypotenuse? Of course there is. It is x squared plus y squared equals the hypotenuse, in this case, 25 squared. Okay, so I kind of explained it before. This is a static equation. But for this to work, for us to be able to solve this, we need to put this thing in motion. So we're going to take the derivative with respect to time. So 2x dx dt plus 2y dy dt. And that's going to equal 0 because this 25 squared, which I didn't even compute, but I know it's a constant. Okay, so now let me plug in the things that I know. The 2 I know, x equals 7 is right there. Dx dt is 2, that was given, plus 2. Now, do I know the y value? Well, right this very second I don't, but if I know the x value is 7 squared, plus y squared should equal 25 squared. So I should be able to solve this thing. Let's see, y squared is 625 minus 49 is 576. Take the square root of that. We get y is equal to 24. So now I can come back over here and put in 24 for y. And I'm trying to solve for dy dt. Okay, so if I multiply these together and move them to the other side, I will have 48 dy dt equals negative 28. And if I divide and reduce, I get negative 7/12. Okay, so the answer is the ladder is moving down the wall at a rate of 7/12 feet per second when the base is 12 feet from the house. Okay, let's try the second one. A woman 1.6 meters tall is walking away from a lamp post that is 10 meters tall. Okay, so let's call this the lamp post. And since I'm not the greatest artist in the world, please bear with me. Okay, lamp post. There's some light coming out of it. Okay, and then there's a woman. And she is walking away. Okay, and let's see, she is 1.6 meters tall. The lamppost is 10 meters tall. Okay, and it's talking about her shadow. So if you think about this, from here to here is her shadow, right? That's her shadow. I'm going to call that y. I just picked a random letter. And then her distance from the lamppost I'm going to call x. And that means that I have two right triangles that I'm looking at here. Okay, what else do we know? The woman is walking at a speed of 1.2 meters per second. So dx dt is 1.2 meters per second. And let's see, what are we finding? How fast is her shadow increasing? So find dy dt when she is 15 meters from the lamppost, when x is 15. Okay, now this equation may not be obvious, and that's why we do these in an example. We're going to use a ratio to solve. Okay, so if you think about, and you may have to look at the picture a couple times, x plus y, which is the base of the big triangle, to 10, which is the height of the big triangle, is proportional to y over 1.6. Okay, so again, that's sort of the big, this is over here, this is the big triangle, and this over here is the little triangle. Okay, now I don't want to have to do the derivative of this the way it stands, so I'm going to cross multiply it. 10y is equal to 1.6x plus 1.6y. And then I'm going to move this to the other side. So 8.4y is equal to 1.6x. Okay, now again, that is a static ratio. It's a proportion. Okay, but over here, when I take the derivative, I will put it in motion. So 1.6 dx dt, right? I did the derivative of this side, is equal to 8.4 dy dt. And now I can put some numbers in, right? Because I know stuff. The dx dt is 1.2. And I'm solving for dy dt. Okay, now you may have noticed I didn't have to use this 15. Okay, and again, sometimes it's going to come into use and sometimes it's not, but I can solve this equation because there's only one unknown. Okay, now I'm not going to lie, I used a calculator earlier and got this to be 8/35. So my answer looks like this. The shadow is increasing at a rate of 8/35 meters per second when she is 15 meters from the lamppost. All right, and I think there's one more example. All right, so at noon, a truck is driving east at a speed of 40 miles per hour. Okay, so I'm going to pick this as my starting point, and there's a truck driving east. An hour later, a second truck leaves driving north. At what rate is the distance between the trucks? Here's the distance between the trucks, increasing at 2 p.m. that day. Okay, so let's see. I know how fast the truck going east is going. That's 40 miles per hour. I also know how the rate of change of the one going north, that one is 60 miles per hour. And I'm going to call this one Z. I'm going to find dz dt. Now, this part takes a little bit of thought. It's when x is 80 and when y is 60, right? And the reason is this truck has been going 40 miles per hour for 2 hours. And this truck has been going 60 miles per hour for 1 hour. Okay, now, this is almost the exact same picture that I drew earlier with the ladder. So this is the Pythagorean theorem. And down here, I can do the derivative of that. 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, now to make life easier for myself and for you, I'm going to reduce that entire equation, meaning I'm going to divide every term by 2 so that I only have to deal with x dx dt plus y dy dt equals z dz dt. Okay, now I'm hoping that I have enough to plug in here so that all I'm trying to solve for is this, right? That's what it says to find. Find dz dt. So let me start plugging in. And if I don't have enough information, I may have to go back in and plug some other stuff in. Okay, so the x value I have is 80. The dx dt that I have is 40. The y value that I have is 60. The dy dt that I have was also 60. I'm solving over here for dz dt, but I am missing a z, right? I do not have a z. So I'm going to come back over here. Let's plug in what we've got, which is 80 squared plus 60 squared equals z squared. I'll let you guys figure that out, but it ends up being that z is 100. So now I can come back over here and put in the 100. Okay, now if you look at that equation that I just wrote, can you see that in here, and in here, these all have 2 zeros, okay? Which means I can reduce this equation, okay? Again, I don't want to have to deal with such large numbers, so I'm going to go through and get rid of 2 zeros here, 2 zeros there, 2 zeros there, which then gives me 32 plus 36 equals dz dt, which ends up being 68. All right, which makes my whole final answer this. All right, be ready to try some of these tomorrow when I see you.